third learning objective in section 3.2 is to find and interpret normal probabilities and values of normal variables using technology, or a normal distribution table. Draw and label the associated distribution. I'm going to be using GeoGebra, which is our preferred technology for this class. If your teacher has taught you how to use the normal distribution table and you prefer that method, you can do that. You'll get the same answers, at least roughly the same answers. They may be off in the last decimal place or two, depending on how much rounding you had to do in your solution. But I'm going to use GeoGebra because it's important for you to understand how GeoGebra works. That is a requirement for this class. The number of chocolate chips in an 18-ounce bag of Chips Ahoy chocolate cookies is approximately normally distributed with a mean of 1,262 chips and a standard deviation of 118 chips, according to a study by the U.S. Air Force Academy. What is the probability that a randomly selected 18-ounce bag of Chips Ahoy contains between 1,000 and 1,300 chocolate chips? Report the probability to 4 decimal places and include an appropriately labeled and shaded sketch of the distribution in your solution. I've opened up a GeoGebra window and I've opened the probability calculator function. I'm in the distribution tab and I've made sure that normal is the selected distribution from the drop-down menu. Now I need to enter mu, which is the population mean. That was given to us as 1,262 chips. I need to enter sigma, which is the standard deviation. That was given to us as 118 chips. And now I'm interested in the probability of being between two values. I'm going to highlight this middle button here with the 2 brackets on either side, and that's what brings up a shaded area in the middle of 2 values. The 2 values I'm interested in are 1,000, so I'll enter that in this first box down here, and 1,300, so I'll enter that in the second box, and then the shaded box to the right gives me the probability I need, 0.6131. There's the probability. Notice that this asks us for an appropriately labeled and shaded sketch. GeoGebra does that for us. So you can see here the peak is at 1262. The distance from the mean, where the peak is, to 118, to the inflection point is 118, which is the standard deviation. And then I've labeled 1,000, and you can see where 1,300 would fall, and shaded the area in between. Or actually, GeoGebra has done that for me. The next question says, what is the probability that a randomly selected 18-ounce bag of Chips Ahoy contains fewer than 1,000 chips? Report the probability to 4 decimal places and include an appropriately labeled and shaded sketch. Okay, fewer than 1,000 means I want the area to the left of 1,000. I'm going to highlight this first button here, which has a bracket facing to the left, and then I'm going to enter in 1,000 in the box, and it gives me the probability I need, 0.0132. My pen to work. There we go. The middle 80% of the 18-ounce bags of Chips Ahoy cookies will have what amount of chocolate chips? Report the upper and lower values to the nearest whole number and include an appropriately labeled and shaded sketch of the distribution in your solution. So I'm going to sketch a little one down here just to point out what's happening. I want the middle 80%. And I want these 2 values down here, which separate those middle 80%. I know that the whole distribution is going to have 80% in it, which means there's 10% to the left and 10% to the right. Now, if I were to highlight this middle part and be able to enter 80% over in the shaded area, then it could give it to me. But unfortunately, GeoGebra doesn't do that. I can't adjust what's going on in the shaded box. But I can use the left button and I can tell it that I want 10% to the left. So I'm going to put 0.1 here. And then it gives me the value that I want. That is 1,110.78. So rounded to the nearest whole number is 1,111. And I also want 10% to the right. So I'm going to push the button to the right and again enter 0.1. And now it tells me that this value down here is 1,413. That's the value rounded to the nearest whole number. And again, this picture down here is a little bit better to show the middle 80%. Our mean is still at 1262. The distance from the mean to the inflection point is still 118. I'm going to do one more example. The total energy need during human pregnancy is normally distributed with mean mu equals 2600 kilocalories per day and standard deviation sigma equals 50. Find the probability that a randomly selected pregnant woman has an energy need of more than 2615 kcal per day. I'm going to enter my new mean into GeoGebra, which is 2600, and enter my new standard deviation, which is 50. And then I want more than, so I'm going to have my area shaded to the right, but I'm interested in 2615, so I'll enter that value. And then I get my probability that I need, which is 0.3821. And GeoGebra gives me my shaded picture. My mean is 2600 and the distance to the inflection point is 50. Find the probability that a randomly selected pregnant woman has an energy need between 2500 and 2750. So now I'll push the between button and I'll enter in 2500 and 2750. And my probability is 0.9759. And there's my shaded picture. And next, above what number of kcal per day is the energy need for the 10% of women with the highest energy need during pregnancy? So I want 10% to be in the right tail. So again, in this area, the box to the right is where I put the area. So that's where I'm going to put 0.1. That's that shaded area there. And GeoGebra then fills in the left box with the amount. I'm going to round to the nearest whole number again, and I get 2664 kcals per day. So GeoGebra is really slick and will do this for us really nicely.